All right, guys, so as you start making your ways back to your seats, we're going to start wrapping up that activity that we just finished, and we're going to move on to some practice problems. In that activity that you just did, you cut apart a cylinder. We broke a cylinder down into the shapes that it's really consumed of. And when we look at these practice problems today, we're going to use the information that we discovered in our activity to help us answer some complicated questions like what are the volume, what are the surface area of a cylinder. Okay? So before we get into any computation, what I want to start off with is two practice problems. Now, this seems very basic, but if we don't start off with this, then we're wasting our time by doing the computation, doing the volume, doing the surface area, if we don't know how to name these figures. And the only one we know right now is cylinder, but we're going to get into some more 3D shapes this semester while we're reviewing. So it's good to make sure that we have a foundation of the vocabulary before we dive into any computation problem. So I know it seems basic, but we are going to name each of these figures in number 1 and number 2. Now, today, that activity that you did, everything had to do with a cylinder. Okay? And we know that it's a cylinder because it has a circle as a base. Okay? It actually has two bases, a top and a bottom, and then they're connected. It's three-dimensional. Okay? So anytime that you have two bases that are circles that are connected, 3D, we're going to call that a cylinder. Now, what's the difference between number 1 and number 2? Okay? One of them's up and down, like a can of soup, and then the other one's sideways. Does it being sideways change the vocabulary word? No, it's still a cylinder, just like on number 1. Just because it's turned sideways doesn't mean anything. Okay? So now that we've got the vocabulary nailed down, and like I said, it's going to get a little more complicated once we get multiple shapes involved. But for now, all we're going to deal with are cylinders. Right? So now let's actually deal with some computation. Right? Find the volume of each figure. Well, we know that it's a cylinder because it has circular bases. Okay? And when you did that activity just now, and we filled those cylinders that you made up with sand, we, as a class, discovered that the formula for the volume of a cylinder is the volume is equal to big B times little h. All right? Now let's talk about this. Big B. That actually stands for something. What does that stand for? Okay, thank you. It's the area of the base. Now, the base is a circle. Therefore, the area of the base, the area of a circle, we've known for years now. You guys have known for 2 or 3 years now that the area of a circle is pi times the radius squared. Okay? So this big B, because it's a cylinder, turned into pi r squared. Now, when we get into some other shapes, like cubes and pyramids and prisms, that big B can turn into different things. Okay? The height is the height. The height is going to be pretty much the same for any 3D shape that we deal with. Right? So we've got pi times the radius squared times the height. So if I look at my shape, one of these letters is already given to me. All right? Which of these letters up here is already given? Okay, good. I'm glad you said the height and not the radius. So I'm going to go ahead and fill in the height, which is the up and down, which happens to be 9 feet. Okay? Now pi is a constant. Okay? And then let's be really careful. Now I know I'm kind of giving it away by not just saying let's slap 16 in there. But let's be really careful when we think about the radius of a circle. Okay? We don't actually have the radius, do we? Okay? We've got the diameter. Okay, now how do I know it's the diameter? Because the little dotted line goes all the way across and it doesn't just stop halfway. If you look at the next example, notice how the dotted line stops halfway. That's how we know it's a radius. So for this problem, the radius is not 16, the radius is actually 8. Okay? It's half of 16. And don't forget to square it. Okay? The most common mistake I see in these types of problems is people forget to square things. Okay? They forget that the formula requires them to do more than just plug numbers in. Okay? And it says round your answer to the nearest hundredth if necessary. All right. So at this point, they're not even really wanting you to do anything other than type it in your calculator, because they say they want it as a decimal answer. If they wanted us to keep it in pi form, if they wanted an exact answer, then we would have to do everything without the pi in the calculator. Right. So what I just did was I typed pi in my calculator. Okay. I'm going to turn that. I thought I was going to turn it up. Okay. So we're going to do pi times 8 squared times 9. Okay. And that's going to give us a volume of 1,809. And it says hundredth, which means 2 decimal places. And we're rounding, so 5, 6. Now, are we finished? No! No way. Why are we not finished? Okay. We don't have our units. Okay. Now, this is feet. And we know that volume is always 3-dimensional shapes. Okay. It's the radius squared times the height. So we've got feet times feet times feet. Okay. Therefore, it's going to be cubed. It's going to be to the 3rd power. Feet times feet times feet. Okay. Questions? All right.